recording live for the future. So here I have an array of base 10 blocks. You could also call it an area. And the question is, what area do I have here? Well, when I look at this picture, so the question I'm asking here is, what multiplication is this? And I see a width here of 10, 20, 1, 2, 3, 4. Or we could say that's the base, depending on how you look at it. And then I see a height here of 10, 1, 2, 3. So it has a height of 13. So this could be 24 times 13 or 13 times 24, depending on your view of it. And I think either one is okay in this case. Now, to get the answer from the picture, we'll look at that a couple of different ways. So this is broken down into hundreds, tens, and ones. If I just look at the hundreds here, I see 1, 2 hundreds, right? 200, 2 times 100. When I look at the tens down here, I see 1, 2, 3, 4, 5, 6. 6 tens is 60 there. And then over here, I have 1, 2, 3, 4 tens, or 40. And then as far as the ones go, this region is 4 by 3. 4 times 3 is 12. There better be 12 right here on a good day. It turns out that I could take that 60 and the 40, and I could trade those in. Trade 10 tens for 1 100. And here's the question. Who cares? Why the heck am I doing this? Anybody want to help give a reason for why bother trading? Simplifying? Okay. Julian, were you going to say something?
I was just going to say, like, so you don't mess up or something like that.
So you don't mess up? Don't mess up what?
Like if you like have a lot of tens.
If you have a lot of tens? Yeah, I mean, basically our whole number system is designed around grouping by 10. Are there enough tens here to regroup them? The answer is yeah. And that's what our number system is designed to do. It's designed to regroup. Because really, I mean, I could say another thing. I could say, well, there are 2 100s here. And I have 10 tens here, don't I? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, there's 10 tens. And I have 12 ones. It doesn't make sense to write that as 2 hundreds, 10 10 tens, and 12 ones, right? That can't be my answer right there. That doesn't look right. I have got to trade those 10 tens in. That's really 3 hundreds. And I have to trade those 10 ones in for 1 10, and then there's 2 ones left over. Okay? So I can't just look at this and say that's 6 tens and 4 tens, so altogether it's 10 tens and leave it that way. It's just not the way our number system works. Okay? So this is just weird to leave it that way. Now, it might not be weird to little kids. They look at that and say, what are you talking about? There's 10 tens there, right? And there's 12 ones. Stop messing with me. But our number system doesn't work that way. We're very used to it. We kind of take it for granted. If we break this down to our expanded, that's a weird 3 algorithm, and I'll write this in a couple of different ways. 3 times 4 is 12, and we just write the 12. That's a 12, right? And then usually we do the 3 times 2, but that's not really a 2 there. That's really a 20 because it's in the tens position. 3 groups of 20 is 60. And hey, there's my 60 right there. And then that's not just a 1 right here. That's 110. And so 10 times 4, or 10 groups of 4, is 40. Coincidentally, not at all. There's 40 right there. And then if I have 10 groups of 20 or 20 groups of 10, either way, I have 200. So every one of the groups of stuff in this block of these 4 regions is accounted for when I look at this way. And then I can group stuff together. Now, although I said there's 12 ones, this 1 naturally fell into the tens column, right? So this trade I have yet to make here, because I didn't write it out specifically, so let's do that right now. right there, I need to trade 10 ones for 1 10. Right? And that just leaves 2 ones behind. So that's this right here. So let's highlight that trade right there. And then what about this trade right there? I don't see that yet. Well, it hasn't happened yet over here, but it's about to. I'm going to consolidate. 2 is the only thing in that column. 1 plus 6 is 7, plus 4 is 11. So don't we usually do that right there? And bang, there's the trade. We just traded right there without even thinking about it. So this right here is that trade that happened right there. And now I can say, oh yeah, there's 300s there. Got it. So we're going to look at this a slightly different way right now. And I'm going to do that using the expanded method. So new page. So again, we're looking at, let's not use red, 24 times 13. And 24 is 2 10s and 4 1s. And I'm multiplying that by 1 10 and 3 1s. And I'm going to write this a couple different ways just for fun. 2 10s, okay, so that's a 20. So 24 is really 20 and 4, 2 10s and 4. And I want to multiply that by 1 10, which is a 10, and 3 1s, which is a 3. Do you remember doing a thing called FOIL in an algebra class where you start distributing stuff in here? Right, where you say, okay, let's take this thing times that, and this thing times that. So 20 times 10 is 200, and then 20 times 3 is 60. And then we do that same thing with the 4. We haven't messed with that yet. 4 times 10 and 4 times 3. So, and I have 4 10s or 40 and 4 3s or 12. Right, that's our expanded stuff using the distributive property here. I could stack the whole thing. 20 plus 4 times 10 plus 3, and write it out like this just for fun. 3 groups of 4 is 12. 3 groups of 20 is 60. 10 groups of 4 is 40, and 10 groups of 20 is 200. So there's a lot of variation on how the expanded works. Typically, if you see it in a kid's book, it's going to look like this version here. Probably you won't see this one, but you might. It'll certainly occur in 6th, 7th, 8th grade algebra classes. You're more likely to see this version of the expanded in most modern textbooks for kids, or these days, a lot of textbooks are online, right? So they're going to be some online thing. I'm trying to remember some of the names of the current ones that are popular. I'm going blank. My daughter's using it all the time and she complains about it. iReady is one of them. It's like part textbook, part video, part practice problems, kind of like the stuff we use here. All right, so what's the point? The point is, why do our algorithms for multiplication work the way they do? Part of it is the implicit trades that have to happen from 1s to 10s, 10s to 100s, and so on up the chain. And then somehow we got to get kids used to that idea, because although it's natural for our numbers to do that, that's only once you're familiar with the numbers, and our kids are still getting familiar with the numbers. So what I would like to do is just ask you guys, is it becoming more clear about how this multiplication area relates to our multiplication algorithms? Does anybody want to see another example? Or are we ready to move on? Had enough of this? Oh, I think a yes just popped up in the chat. Is that true? So was that yes, do another, or yes, I've had enough? Sorry, I asked too many questions.
It's just making sense.
It's starting to make sense now. Okay. All right. So I'm going to pause. No, I'm going to continue because this is still review. All right. We're going to move on to subtraction then. All right. So subtraction models. Subtraction models. We have two main models and then kind of a couple of side models for subtraction. So the main ones I'm most concerned about are one, the takeaway model, and two, the comparison model. Oops. Comparison first, comparison. So I'm going to focus on those two. Other models that we've talked about are the missing addend model and the number line model. And I think the last two are a little pretty straightforward. On the activity on the subtraction models, that activity was on takeaway and comparison. About half the class had a little bit of trouble communicating to me what I was hoping to hear. So I just want to make sure we're on the same page on this because this is definitely going to be on the exam, and I want to make sure everyone has a good chance of coming up with a good explanation of the difference between the two. So takeaway versus comparison. So we're going to do a couple of examples of this we're going to throw in base 10 blocks and we're going to write some stories. So let us come up with a couple of problems. Oops, wrong way, that one. Let's take, how about 34 minus 16. That should work just fine. So 34 subtract 16 is what I have there. And there are two different ways we can do this. So we're gonna write some stories and draw some pictures. So what we want to do for this is we want to do the takeaway model. With the takeaway model, we want to come up with a situation for it where things get taken away. So write a story, and then we want a base 10 picture of this. And the point of the base 10 picture of this is to get at our algorithm. And our algorithm is often called the borrowing algorithm, but its real name is like the renaming algorithm. And we'll talk about why again. So main things is we want to come up with a story or situation that involves a takeaway. We want to come up with a base 10 picture that relates to the way we would write this down in our algorithm. And we want to do almost the same stuff, but based on a comparison. We need to come up with a situation for that comparison. If I can spell situation. Go. We want to have a base 10 picture to go with it. And the point of that picture is to kind of think about how our algorithm works, why our algorithm works for it. So I'm going to pause this recording. All right, so here's my stories. So here's my 34 bucks, and I can't give Julia right now because I have 3 10. I can't give Julia $16 because I have 3 10s and 4 1s. I can't make $16 out of 34 in this manner. And if I go to those blocks, like the base 10 blocks here, and you think about the takeaway, right? I want to try and take away 16. Okay, so here's I took away 1, I took away 2, I took away 3, I took away 4. Ooh, that's 14. Should I give her 24? No, I'm not giving her 24. I'm only giving her what she asked for, 16. I worked hard for that money. What am I going to do? Help. I can't. I just want to give her a couple more, right? So I've got to trade that in, right? There's no way around it with the physical toys or if this were physical money. Now, with the Pokemon cards, that's a little trickier because Griffin has 34 individual cards. But the point here is I'm trying to use base 10 blocks to get to how the algorithm works. So let's look at the algorithm before I continue with my pictures. I'm not done with either picture. I hope that's obvious. As far as the algorithm goes, we write 34, and then underneath we write 16, and we line up the place values. We put our subtraction symbol. And then we try to say, okay, what is 6 from 4? And we realize we can't do it. So then we go over here and we scratch that out, change it to a 2, and throw a 1 over there. Okay? And hopefully kids get that we just rewrote 34, which is 3 10s and 4 1s. We just regroup that as 2 10s and 14 1s. It's the same amount of money. It's the same amount of stuff. We just regrouped it different. I now have 2 10s and 14 1s, right? I can totally do that with bills. Pokemon cards, that's a different story. But regardless, this is the way the algorithm works. Doesn't matter whether I'm talking about Pokemon cards or money. So now I can take 6 from 14. That works. I'm going to get 8. And then 2 take away 1, or really 20 take away 10 is 1. So there should be 18 left over. So in order for it to work down here, I have to come over here and trade 1 10 for 10 1s. Otherwise, I cannot continue. So then this sucker is gone, right? I'm cashing that thing in, scribble it out. Sorry, I'm having trouble tracking there. And so I'm trading it in for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now I can get amongst doing the takeaway. Okay, so I'm going to give Julia, let's just give her a whole 10, right? So let's just take that away. And then I'm going to give her this one and that one and that one. She's got 14, this one and that one. Now I've taken away 16, and I can see that leaves a 10. This one's been obliterated. So I have 1 10 for sure, and then 1, 2, 3, 4, 5, 6, 7, 8 1s. 18 left. Okay. But we got to do that trade, otherwise we cannot do the takeaway. Similarly here, I can't do the comparison because there's not enough 1s to compare over here. I run out. I can say, okay, this guy matches that guy, and this guy matches that guy, and this guy matches that guy, and that one compares to that one, and this one compares to that one. And you could say you're done, but you're not, because he still has stuff and he still has stuff. So we have to cross this guy out and trade. And then I'm going to make them circles so they're easy to draw. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I can keep comparing. This one compares to that one, and this one compares to that one. I'm done comparing. Griffin has, how many more? 10, and looks like 8 1s, 18 more. But these are solid pieces. You can't just start checking off. So to make that more clear, I could get rid of my grid. Bye-bye grid. Oops. Oh, shit. Wrong button. Sorry. Excuse me. Share. There we go. Okay, so no grid. So I can't pull a 1 out of here because there's no 1s to take unless I go to the bank and trade in that 1 10 for 10 1s. So a variety of things. There were all kinds of different problems on the activity 3.2b about subtraction, takeaway versus comparison. One was not everybody had reasonable stories or stories at all. 2, we wanted to definitely show trades where trades had to happen. Otherwise, the takeaway does not happen. So that needed to be there too. So I hope this is a little more clear. Does anybody want to ask some questions based on what they tried and what I'm showing here?
I didn't really have a question about it. I just wanted to say that what you're doing now, it's kind of the canceling out of the groups and making them singles. Is that what you're wanting us to convey in our work when we do it? You just definitely want to see that because that's what I'm getting.
Yeah, so in a lot of problems, so you're definitely going to see problems like this on the exam. I'm going to have something like illustrate and explain. And it could be an addition problem, a subtraction problem, a multiplication, or a division problem. And sometimes I'll even tell you which model to use, but sometimes I won't. And it's up to you to pick a model. And every model should have a question or a story to go with it. And then sometimes, like with addition, we have to carry. What does that carry look like with base 10 blocks? That means you're going to take a group of 10s and trade them in, or sorry, a group of 1s and trade them in for a 10. Or maybe you're going to take a group of 10s and trade them in for 100. So somehow you have to convey that that happened. And I had, let me show you another example while we're on the subject. Let me get to my Google Drive. And, oh, we're over time. I'm sorry. Can I take just 2 more minutes? Is anyone dying to just get the heck away from me? Just hang on just a couple of minutes. With respect to the multiplication, I wrote up a paper, and let's put this in a new screen. Let's see, how do we do that over here? Open a new window. Let's blow it up a little. All right. So, I have a 2-page document. I'll share this with everybody so you can see it. So in the videos I do with you guys, I kind of show a process. And usually what happens is, we're doing it all together and we just end up with the end result, right? So on paper, I would be talking and explaining, and I would, I just magically end up with this end result right here. For, like, say if somebody asked me, could you explain why 14 times 23 has a certain answer? So this is one way to explain that. And to get to this picture, though, there's a whole bunch of stuff I'm doing, right? So the first thing I have to do is I have to think of 14 in one direction and 23 in the other direction. And then I actually have to mark off the 10s and the 1s, right? And then third, I got to say, okay, there's groups. There's a group of 200, a group of 30, a group of 80, a group of 12. And then that's related to the expanded algorithm. So this was the activity 3.3. I'm halfway through grading these. Sorry, I'm so slow. So if I didn't get to yours yet, hopefully tonight or tomorrow I'll get it done. And then finally, I put it all together with the trades. So I kind of broke down explaining multiplication with base 10 blocks and the area model. It takes me 4 steps in my head to do it. But I don't usually draw 4 different pictures. That all ends up in one picture right here. So here's me thinking the 4 steps in this page, and this is like the end result. Okay. So with respect to the activity 3.3, where I gave you those 4 multiplication problems, and I said, draw me an area with base 10 blocks, and then show me how the area tells us what the answer is, and how does that relate to the expanded algorithm. So for each of those problems, I was hoping for something like this, where you showed me your whatever times whatever, that you had some markings inside. Sometimes trades were necessary. On 3 of the 4 problems, trades were necessary, and then the expanded algorithm to go with it. So each answer should have looked something like this right here. And sometimes people were missing the trades, or their pictures weren't quite right, or the expanded algorithm maybe was missing. So if I didn't write back to you yet, you will probably get a copy of this document in my comments about your work, and maybe some videos where I was walking through it in class with you all. All right,